Small models, big data, real returns. Large language models burst into mainstream attention with the arrival of ChatGPT, kicking off a massive wave of investment and integration attempts across industries. Yet, MIT Media Lab research recently highlighted a sobering reality. A striking 95% of generative AI investments reportedly yield zero business returns, not due to technical failure, but misaligned business needs and overhyped expectations. Many organizations race to either build their own models or bolt in generic LLMs, chasing feature parity rather than delivering value. Emerging evidence points to small language models, SLMs, specialized, domain-adapted models trained on business-specific data, as a practical solution to the return on AI dilemma. One developer's open-source project, Otto, exemplifies this trend. With just 16 million parameters, architected as 6 layers, 6 attention heads, 384 embedding size, Otto was fine-tuned on 142 megabytes of automotive customer service transcripts from Hugging Face. Notably, training loss dropped from 9.2 to 2.2, and the model demonstrated an ability to internalize technical vocabulary and conversation patterns unique to its industry, far outpacing off-the-shelf LLMs on specific tasks relevant to its user base. However, the SLM approach is hardware-sensitive. GPU-accelerated training remains key, with CPU-based methods lagging badly in both speed and inference quality. Community feedback highlights the need for consumer-friendly CUDA and Metal support and modern quantization, 4/8-bit, plus support for LoRA QLoRA adapters to democratize domain customization for small business users. While enthusiasm is warranted, true business value still depends on the fit between specialized data, scalable infrastructure, and realistically scoped use cases. Evolving reasoning, local LLM power, LLMs continue to evolve, and the open-source world is busy benchmarking the next generation. Qwen3 Omni, Alibaba's latest thinking model, stands out as a significant leap over v2.5, particularly for advanced reasoning, memory, and real-world awareness. Testers running the 30B parameter thinking variant on an H100 workstation observed impressive results using FP8 dynamic quantization and 32K context windows. Qwen3 Omni handled nuanced context well, even catching nonverbal inputs like boop-boop sounds, and proved capable of tool calling, an increasingly critical feature for integrating external apps and services. However, the thinking model lacks native audio output, unlike some Instruct variants, and demands substantial RAM. Community tools such as Gabber, a comfy UI-like interface for multimodal models, are making these advanced models approachable for more users. But speed remains a bottleneck for use cases demanding real-time conversations or high concurrency, such as live translation or job interview simulations. Optimizing for reduced latency in streaming LLM responses is currently an open challenge for even the most cutting-edge models. The appetite for 4-bit quantization and efficient inferencing frameworks is high, with VLLM, TensorRT LLM, and text generation inference TGI vying to unlock the full performance of modern GPUs, including multi-GPU rigs with L40S or dual H100s. Just as critical as raw throughput is seamless tool call integration. The debate between emerging tool calling protocols, most notably MCP, Model Context Protocol, and the simpler UTCP, reveals that, for most local setups, the protocol overhead is negligible compared to LLM inference time. MCP wins on ecosystem maturity and error handling, cementing its position as the pragmatic choice for now. Claims around UTCP being 30 to 40% faster do not hold up under realistic workloads, where the LLM itself, not JSON RPC or WebSocket communication, is the dominant bottleneck. Hardware hacking and optimization realities. Behind these software advances, hardware tuning is as critical as ever. A recent breakthrough for AMD's Strix Halo laptops, accomplished not with hacks but a simple Linux kernel upgrade to 6.6.9, restores the full 96 GB VRAM allocation for ROCm, overcoming a notorious memory limitation. This upgrade unlocks running top-tier models like Llama 3.370B or GPT-OSS 120B on a single machine, a dream scenario just a year ago. While technically possible to split model layers across CPU and iGPU, the consensus is clear. In shared memory architectures, like Strix Halo's APU, sticking with the GPU for the entire workload maximizes performance. Unlike dedicated GPU plus CPU offloading, used when VRAM is scarce, These unified memory systems benefit little from offload tricks, since both CPU and GPU draw from the same memory pool. The broader hardware discussion increasingly centers on systematic approaches to maximizing multi-GPU rigs, with special attention to topologies, PCIe 5.0, NVLink equivalents, and distributed inference frameworks. Major speed wins come from fine-tuned tensor and pipeline parallelism, careful quantization choices, and leveraging frameworks like PyTorch, FSDP, DeepSpeed, and VLLM. It's a far cry from the plug-and-play era, but for now, squeezing every last bit of inference speed is a technical art and an infrastructure arms race. RAG under the microscope: quality, drift, cost. Retrieval augmented generation, RAG, feeding LLMs with external context through vector search or document retrieval, promises higher factuality and domain accuracy. Yet, real-world deployments reveal persistent pain points as labs move from demo to production. First, retrieval faithfulness is non-trivial. The nearest neighbor results often appear relevant yet inject shallow or downright wrong answers. Teams are beginning to measure retrieval precision recall, even using LLMs to judge faithfulness, breaking away from feel alone. Second, drift bites hard. As new documents or embeddings shift, accuracy quietly decays. Logging retrieval traces is not enough. Robust observability and alerting systems are becoming indispensable. Finally, costs balloon, whether from excessive latency, runaway tokens, or brute force vector searches. Vector database choice, Pinecone, Chroma, etc. matters, but brute force can be surprisingly efficient at small scales. Perhaps most notable, even the best retrieval pipelines cannot substitute for clear benchmarking and cost analysis. Achieving scalable, reliable, and cost-controlled RAG pipelines remains an open challenge, with observability stacks and automated drift detection now seen as foundational for mature deployments. Vibe coding, context, and game engines. Vibe coding, a term popularized by Andrej Karpathy, captures the growing trend of leveraging LLMs as a kind of high-level programming language for rapid prototyping, especially in game dev. The core idea: let the AI just build it from intent, not lines of code. As early experiments showed, this works astonishingly well when project context is small, but as the codebase grows, LLMs begin to flounder, suffering from context window overflow. Ad hoc solutions emerged, such as context management scripts for Claude Code to load to update context, but scalability remains an issue. Evaluations of vibe coding across Roblox MCP, Unity MCP, and web stacks revealed a truth. Models perform best in open, well-documented, and high-abstraction environments. The web, despite lacking batteries-included game engines, offers the highest AI proficiency, likely due to its massive training data. New platforms like VibeGame aim to fuse high-abstraction declarative game engines with familiar XML-like syntax, with transparent documentation for the AI, striving to keep codebases lean and projects LLM-friendly. Even as new frameworks make vibe coding less error-prone, the real bottleneck remains. Unless domain knowledge is encoded, either in the engine or in the prompt context, LLMs hit hard limitations. For now, treating LLMs as supercharged helpers, not one-shot programmers, is the most productive stance. Decentralized creative AI, MusicSwarm, and Emergent organization. AI-generated music has so far relied on monolithic models, large LLMs trained end-to-end, yielding coherent but often uninspired results. MusicSwarm, a new research framework out of MIT, takes a radically different approach. A swarm of static foundation models, bar-level agents for music generation, interact via stigmergic, pheromone-like shared signals. Crucially, no agent's model weights change. Instead, structure and creativity emerge from how agents influence each other. In controlled tests, the decentralized swarm system dramatically outperformed both monolithic AI composers and even centralized multi-agent systems. Outputs generated by MusicSwarm displayed richer thematic development, greater structural complexity, and higher creative diversity, the emergent product of peer-to-peer influence and musical cues, embedded in shared memory. The system avoids typical creativity traps like repetitiveness or lack of thematic bridging, simply through interaction protocols, not more data or longer training. Beyond music, the underlying insight that intelligence and creativity can be properties of organization and communication, not just larger or smarter models, hints at new architectures for collaborative AI in text, design, even science. It's a paradigm shift from model-centric to organization-centric AI. Open models, tool use, and the expanding LLM frontier. The arms race for larger, more capable open models is pushing the boundaries across code, reasoning, and tool use. Cohere Labs' Commanda Reasoning, an open 111B parameter release, brings 256K context, advanced multilingual reasoning, 23 languages, and built-in agentic tool use via MCP and chat templates. Of note is its explicit reasoning mode. Users can toggle detailed step-by-step rationale for outputs on or off, plus seamless JSON tool schema integration for LLM-powered workflow automation. Early feedback highlights flexible tool call handling, including citation grounding, making it one of the more research-friendly open weights alternatives in the agent space. On the deployment side, practical integrations are flourishing. For instance, the new MCP server, Reddit MCP Buddy, lets Claude Desktop natively browse Reddit in real time, summarizing threads and trending topics through tool calls. Combined with platforms like Jan.ai, Qwen38b, and the broader MCP-compatible ecosystem, this workflow brings rapid, composable RAG-like augmentation firmly into local LLM hands. For development teams, this means the tool calling protocol wars are no sideshow. Ecosystem maturity, error handling, and flexibility, e.g., citations, tool output spans, are becoming as important as underlying model quality, especially as LLMs anchor more of the software engineering and automation stack. Diffusion models, image generation, and alignment advances. Text-to-image and diffusion models remain a hotbed of academic and open-source innovation. The Chroma 1 base model, built on top of Flux.1 with 8.9b parameters and released under Apache 2.0, represents a truly community-driven effort. As a base model, it is intentionally left neutral and easy to fine-tune, designed for transparency, low barriers for extension, and full compatibility with both Hugging Face's diffusers and Comfy UI workflows. Modifications like MMDI masking and custom time-step scheduling boost fidelity and stability, but model alignment, bias, and safety are left in developer hands. Tencent's new SRPO method goes even deeper on alignment, introducing a reinforcement learning approach that directly regularizes diffusion model behavior with graded, fine-grained reward signals. SRPO's novel sampling and optimization scheme enables efficient restoration of highly noisy images and supports dynamically controllable text conditions, allowing users to style condition generation on the fly without expensive KL constraints or external reward systems. The team also releases training, inference code, and comprehensive workflow tips, including strategies to combat reward gaming, overfitting to colors or oversaturation, and to scale to new data regimes. MV-RAG from Hebrew University addresses a persistent challenge in text-to-3D generation, out-of-domain OOD concepts. Previous diffusion-based pipelines faltered when prompts referenced rare or unseen objects, as 2D priors and limited 3D datasets yielded mode collapse and poor geometric consistency. MV-RAG bridges this by feeding in-the-wild 2D images retrieved via CLIP or similar retrieval models directly into the multi-view diffusion model, fusing these with learned priors through an adaptive attention mechanism. This hybrid model shows striking gains in OD prompt fidelity, 3D consistency, and photorealism, and doesn't require per-prompt personalization or expensive fine-tuning, substantially advancing the state-of-the-art in generalizable generative AI. Linux hacking, distro hopping, and workflow survival skills. For those living in the open-source trenches, distro hopping, habitually switching Linux distributions, remains a rite of passage and a recurring technical headache. The Hackaday community's deep dive underscores a universal lesson. While tools like VMs, live images, and .file repositories ease transitions, the fundamental complexity of migrating custom environments, separating data from system, and unwinding baffling config breaks has not disappeared. Advanced users embrace scripting, automation, and regular system-agnostic data backups, but even the pros concede there's no perfect, universal workflow migration strategy. Laziness is a virtue when it comes to avoiding unnecessary hops, and learning to reconstruct rather than port is the path of least regret. The Geolocation Starlink and the limits of internet mapping. As connected devices proliferate, accurately mapping users' physical locations based on IPs becomes crucial and increasingly fraught with error. While legacy telecom systems embedded location info, the internet does not, leaving researchers reliant on external databases and statistical inference. APNIC Labs' ambitious country-level geolocation strategy, melding population estimates, Google Ads traffic, and BGP routes, works surprisingly well for major ISPs, but falls apart in the face of borderless ISPs like Starlink. The Yemen case study is instructive. APNIC's measures attribute 60% of Yemen's internet users to Starlink, a figure almost certainly driven by cross-border use, maritime traffic, and reseller manipulation, rather than local infrastructure. Starlink's practice of registering all device usage to the point of purchase, regulatory location, not the actual spot of service, distorts country-level attribution. As satellite ISPs, CDNs, and mobile-first providers continue to expand, geolocation will only get harder, not easier. For now, 15% margin of error is considered success, with edge cases and gaming remaining pervasive, reminding us that network reality often slips beyond our measuring tool's grasp. Security tooling, Ethereum address poisoning simulator. Security research tools are increasingly open-sourced for ethical hacking and education. A new Python tool, released for simulating Ethereum address poisoning, where attackers create vanity addresses resembling targets and inject low-value transactions to pollute wallet histories, provides a hands-on way to study and defend against this widespread scam. Complete with address generation, transaction broadcast, and detailed reporting, the tool is strictly licensed for research and ethical use, but it underscores the centrality of hands-on testing in modern security. Theoretical knowledge alone doesn't cut it.